Once again, welcome everyone in today's webinar. Some of you attended our previous session. For the person that are joining us in that coffee demo series for the first time, I would like to give a little bit of introduction. So we are meeting here today, a few of us. Our main guests in today's webinar are Rudy Boblit and Tim Brandwood from Digital Taxonomy, our dear partner. Been quite busy for a few months already, and there will be even more coming up. We also have Peter Takac, he's my colleague from here at Nebu. He's here to help me in case there are more technical questions regarding Nebu Dub InterViewer and our data collection tool. So to give you a little bit of context of what are we doing here. So last year we started building up this a coffee demo. Why coffee? Just because we like coffee and we wanted to have some storyline behind all those technical magic we are doing here. So we started last year. We hosted a webinar together with Rudy from Digital Taxonomy, where the goal was to present something very cool. Last year we have implemented a new functionality in Nebu Dub InterViewer, our core data collection tool, that is ability to make advanced HTTP request calls, so really like API calls in real time to any third-party tools, to retrieve data in real time, to post data in real time. And in this webinar, we focused on cooperating with Digital Taxonomy. Based on a simple NPS questionnaire, we managed to show how you can make your Nebu Dub InterViewer questionnaires actionable. So pretty much the goal here was to ask a classical NPS question, ask for the experience, to give a score. Then we were asking open-ended question. We had a nice first advanced HTTP request call, because this is like multilingual questionnaire. In the first call, we managed to in real time to translate open answer into any given language. I think we picked English for the purpose of demonstration, so everyone understands. And then from here, we were already making advanced HTTP request calls to Codeit, to one of Digital Taxonomy tools, to retrieve a sentiment of this particular verbatim. And based on real-time callbacks from Digital Taxonomy, from the sentiment, and a few other elements like recognizing brand name, etc., we were actually triggering real-time actions directly from the questionnaire. So we were posting tickets to support team for very negative comments coming from, for example, from brand promoters. We were triggering emails to innovation team for all the passive that gave us very nice idea of how we can wow them, and we were posting some of very positive open answers already as a reviews of our demo coffee on a landing page. So that was the start of our project. If you're interested to see that, all of those webinars are available in the library in the tab webinar. So this is making data actionable. This was the first one, and then this particular webinar was followed by 2 sessions, but they were meant strictly for Nebu customers, Nebu users. So in those 2 sessions, we actually in details presented how you create those advanced HTTP request calls and how you script them into your questionnaires. If you are a Nebu Data Suite user and you didn't see those, please reach out to marketing@nebu.com. I will share those recordings with you. And finally, today we have Tim and Rudy that will show and explain actually what this magic black box that is digital taxonomy contains. So what are actual methods of how you can implement AI and machine learning into your Nebu Dub InterViewer questionnaires. And the goal here is to present you how those methods can help us create really smart, interactive questionnaires. And maybe last element is also to mention that what we are building right now will be a bigger project that we will present this autumn during the Association of Survey Computing Conference in London. It was supposed to be in May, but for an obvious reason, it's rescheduled for the autumn. Hopefully it will happen in autumn. So stay tuned, there will be much more coming up in our project. And from here, finally, after the long introduction, Tim Root, welcome. Please,
thank you very much.
Take the stage is yours.
Okay. Let me just switch over to screen sharing. I'm hoping you can see my screen. Okay.
Yeah.
Yes, good stuff. Okay. Yes. So thank you very much for that introduction. And as was mentioned just now, I'm Tim from Digital Taxonomy. I'm joined by Rudy, also from Digital Taxonomy.
Hello, everyone.
And yes, we've been working with Nebu for a good few months now, looking at ways in which we can integrate our software and all the sort of smart stuff that exists within that with Nebu. And since this series was all around linking Nebu to third-party products using HTTP calls, this seemed like a perfect fit because it's exactly the sort of thing we support with our software. So the goal for me today is to give you a bit of a sort of up-close view of how the sort of automated coding side of things can work through the Codeit API. All that sounds very technical, and there will be some technical bits in here, but I think all of this stuff should be kind of fairly intuitive to a non-technical research audience. So yeah, let's get started. So as was mentioned in the introduction, Codeit is sort of our flagship product. It's around about coming up for 4 years old now, so it's a fairly mature product. And if I just switch over to the software itself, it's probably easiest to explain what it does just by showing it. First and foremost, Codeit is designed to be a tool for coding open-ended responses. Now, I'm going to assume that given the audience we're talking to today, all of that terminology will be familiar to you, and the process of coding should be something that you've had experience with or you're involved with. But essentially, when we collect an open-ended question in a survey, if we want to analyze that open-ended text, we usually have to sort of convert it into some sort of quantitative form in order to be able to add it up and analyze it. So Codeit is a tool. I would argue it's the best tool in the world for doing this task, and it should all be fairly obvious on screen. Sort of what's going on here. We've got a set of verbatims in the center of the screen here. So these are open-ended responses given to us by respondents, and on the left-hand side are a set of themes that either we're looking for in this data, or we're expecting to find, or the client wants us to kind of code against. And at its heart, Codeit is a method that allows you to, allows coders to read the text and apply codes to the data. Okay, so that's all should all be fairly self-explanatory and fairly obvious. The data we've got here is some data that I scraped. It's from IMDb. It's reviews of Stranger Things, which is a fantastic series that I'm watching at the moment. I thoroughly recommend it if you haven't seen it. And so, yeah, at its heart, Codeit is just a tool that allows this process of converting text responses from a survey into quantitative coded data. So we are all about that transformation, and we are also about finding ways of automating that transformation as well. So using smart technology to turn open-ended verbatim data into coded, tagged data. So a byproduct of that is that we allow or we enable people, like third-party users, to tap into all of that sort of smart stuff via our API. So I'm just going to switch back to PowerPoint here and draw a picture of what that might look like. So it's a very high level, but it essentially, through our API, we allow an open-ended text to be passed in, and sorry, it's on it's on an automatic build here. So yeah, text can be passed into the API, and through the magic of Codeit, we can then send back closed response suggestions using the technology built into the software. So in principle, that's how we expose our technology to the outside world, and also obviously to Nebu. So before I sort of dive into some of the the details of how you set that up or how you connect to that API or whatever, I just sort of thought I'd start at the other end of the process and show you what the end result looks like when we link together these two pieces of technology. So I'll show that, and then I'll kind of talk about all the bits in the middle and get into some of the details. So we've got a questionnaire here. Yeah, it's about it's about a cafe, and we're asking, our first question is asking what was the person's reason for visiting the cafe. Now, in our hypothetical cafe scenario here, we are the client is looking for two things. The cafe is running a promotion at the moment, and they want to see whether people spontaneously mention the fact that it was the promotion that brought them into the cafe. But they're also looking to find out who they visited the cafe with. So was it, did they bring their children? Did they come with friends? Was it a work thing? Whatever. So obviously this question is very, very broad and open deliberately to allow the respondent to say whatever it is that's relevant to them. So if I was to say, I saw the special offer outside, okay, then that's telling me, the researcher, that it was the promotion that brought that person into the cafe. But that response doesn't tell us anything about who they came to the cafe with. So when I move on to the next question, the questionnaire sort of specifically asks, because we don't know from the first question, it specifically asks, well, who did you visit with today? Okay. So let's say I was meeting my boss, something like that. Then when I move on to the next screen, you'll see that this question is tailored to the response I gave in the previous question. So because we know that the respondent was visiting the cafe for sort of work or business reasons, we ask a question that's specifically tailored to that. So I might say the table was dirty. Okay, and then the next question is asking. Hang on, sorry, I'm going to go back. Was, I don't know, not clean, let's say. So the next question here has picked up on the fact that I'm I'm unhappy with, I mentioned something about the cleanliness of the cafe in the previous question. So he's asking me another question that is tailored specifically to the, the aspect of cleanliness. So again, this question is being rooted specifically because of what I've mentioned in the open-ended question beforehand. And that's, at this point, is for this particular respondent, is the end of the questionnaire. Okay, so you can see there that it's fairly unobtrusive to the respondent, because all the magic is happening in the in the background. But yeah, as I'm giving my responses, my open responses here, Nebu is passing that text back to the Codeit API, and the Codeit API is then sending back suggestions of what topic or sentiment is being discussed in that response. And then there's logic in the Nebu questionnaire which will route the questions accordingly, as we just saw a minute ago. So that's great. Now, before I show you some of the sort of inner workings of that, just want to take a sort of another step back. So if we look at an example, oops, sorry, we've done this one. It would be great if we could just magically throw any piece of text we like into this black box, and Codeit will just tell us, with no other information or no other context or setup or anything, exactly what that theme, what theme that text relates to. But if we think of an example, if even before we think about AI, just from a common sense point of view, if I was to say to you the phrase, "I thought it was really cheesy," could you tell me exactly what theme I'm talking about here? I mean, the answer is fairly obviously no, because there's not enough information or context within that text to make it unambiguously clear what it is I'm actually talking about. So it could be that I'm talking about a film, in which case I thought it was really cheesy. The theme there is negative comments about the film. But if I was talking about a pizza, then obviously that's a positive thing. So that could be coded as positive mentions of food. So it's kind of important when it comes to AI. It's kind of important to bear that kind of thing in mind, because it's easy to get carried away and think that AI is magical, and you can literally throw anything at it, and it'll just automatically know exactly what you're talking about. To take another example, previously in our Stranger Things example, we had this verbatim here. It's like stepping into a time machine, and the list of themes that we're looking to tag against contains this first code here, 80s retro nostalgia. It's easy for us as humans to see that those two are paired, but without any information about what specific themes I'm looking for, the machine, the AI can't just automatically know that I as an analyst need to know that, or would categorize Time Machine as 80s retro nostalgia. See what I mean? There's a certain amount of stuff that the machine learning can do and AI can do if we give it the kind of information that that it needs. So if we kind of fill in some of the blanks and give it the context and give it something to work with. So for example, in here, if we were able to tell the AI that this is a you know, it's a pizza study and the context is pizza, and, you know, these kinds of comments generally should be coded as, you know, positive pizza comments, then the AI has a fighting chance of being able to do that for us. But without that kind of crucial bit of kind of extra information or setup, you know, AI can't just do everything. It unfortunately isn't just a total sort of magic black box. So I think the point I'm coming around to here is that there's, in order to get it to work the way we want it to, there's a bit of setup and kind of work we need to do on our side in order to kind of give the AI the you know, the information it needs in order to be able to do its job. So let's go back to the questionnaire and look at some of the mechanisms that are at work here. I've actually got a second instance of this survey here, which will show me some debug information as we go through. So let's say I answer this question by saying, go back to the example we had before. I saw the special offer outside. Okay, so when I move on to the next page here, we can see that the you know, Nebu sent the text or this as a JSON request to the Codeit API and got back a list of suggestions. There's actually only one in the list here, but a list of suggestions telling us that it thinks this text should be coded as triggered by promotion with a confidence score of 100%. So if we switch from our Stranger Things project to this project here, we can see how we can sort of see peer behind the curtain and see how Codeit has in this case how Codeit has managed to produce that suggestion with that level of confidence. And it's pretty simple. What we've done is we've given Codeit a list of example verbatims and how, you know, information about how they should be coded, and it's using this information to generate these suggestions. And this is the point I was making a minute ago about how, you know, AI can't magically know these things, but if we give it some examples, it can learn from those and it can use that example data to do this job for us. Now, this is a really simple case because the text that I typed, I saw the special offer outside, actually matches exactly a previous verbatim that we fed in as training data. So obviously, you know, that's a very simple cut and dried example of the system saying, aha, yes, I've seen this verbatim before. I know that this needs to be coded as code 2 triggered by promotion. And that's why you know, the response we get back includes that as a suggestion with a very high confidence score. Interestingly, if I, and I'm going to show you the same example again using Postman, which obviously we covered in the previous session. So if I put, I saw the special offer outside. Again, same result, exactly the same mechanism. That text is going in. These results are coming back from the Codeit API. That's you know, same mechanism at work here, and that's, you know, that's going to work great when common repetitive things come up. But obviously, the shortcoming of this technique, you know, is if the respondent says something, you know, if we're literally just using this text matching technique, if they say something different that, you know, differs from the exact verbatims from before, then we'll come back with, in this case, no suggestions at all, because there isn't an exact example that matches that text that I typed in. Okay, so that's, you know, one technique which works some of the time. And we're going to come on to sort of more sophisticated stuff in a minute, so don't panic. That's not the extent of the AI, just simple text matching. But it is a useful technique, because sometimes two people do just say exactly the same thing. So that's an easy win. Okay. Now let's say the respondent said, I was meeting my boss. That's going to come back with the suggestion of work or business meeting. So from my predefined list of codes that I'm looking for, that one's coming back, which looks correct, obviously. But within this list of previous examples, there isn't an example of somebody saying I was meeting my boss. That's that's obviously using a different mechanism to get to that code. So that sort of brings us to a sort of second layer of the Codeit AI, where I, as as the sort of script writer, or the person who sets all this up, I can bring my contextual knowledge to bear on this and tell the system about certain keywords or phrases that come up and what they mean. So it's a different way of training the system. Rather than just giving it literal examples, I can say, look, if I happen to know that if the word boss comes up, I just want that to be coded as work or business meeting. So within the code frame that we've defined here in Codeit, we've got the ability to attach text matching rules to each code within the code frame. So if I click on here, you'll see that it's a very simple rule, obviously, but I've defined a rule that says, if the text work or boss appears within the verbatim, then make the suggestion code 4. So that's where Codeit is detecting that presence of that word, and then that's triggering that rule. And if we wanted to, we could maybe edit that and say work, boss, client, whatever words happen to be relevant for the case at hand. And then if I say, I was meeting my client, hopefully we should see that the same result comes back. Again, this is another example of AI doing some clever stuff for us, the system doing some clever stuff for us, but it's able to do that because we are configuring it and giving it some information about how we want things to be coded. We haven't got, arguably, we haven't got to the level of full AI yet in the examples we've looked at. These are fairly simple techniques, but for something like this, where we are, the client is looking for very specific things, so like promotion, adverts, special offer, things like that. There are obvious text matching rules that you can create and implement in the system that will be surprisingly effective. So although they are simple techniques, it doesn't make them any less valid. If they work effectively for what you're trying to achieve within the survey, then that's great. Okay. Now the downside of both of the techniques that we've looked at so far is that they do rely on us either having literal examples. So I saw the special offer outside, or preempting every single type of example or keyword that might come up. Okay, so let's supposing instead that the respondent says, I was meeting my customer. We're going to have a problem, right? Because we haven't, within our examples here that we fed in, and within the text rules that we've come up with, there is nothing that tells the system, or there's no examples the system can draw on in order to know what this phrase should be coded as. They are the limits, or the limitations of simple text matching techniques. In order to get beyond those limitations, we need to apply full-blown machine learning and proper artificial intelligence. So within our questionnaire, if we move on slightly, let's say I came with my friend, asked this question. Okay. Sorry, let's go back again. I want the debug one. Okay, I was meeting my bosses, for example. Okay. So in this question, what did you think about the cafe on your visit today? If I was to say something like, the barista was very friendly to me. Okay, we want. Sorry, if I jump back to Codeit here, you'll see that for question 3, we've got a code frame that consists of 3 themes that we're looking for. So in routing this questionnaire, we want to ask a follow-up question if cleanliness, service, or coffee come up as themes. So again, we need to give the system some information about how we want these things coded, and I'll come back to how we've done that in a minute. But if I say something like, the barista was very friendly to me, okay, there's nothing in the example verbatims that we've put into the system that contains the word barista, I think. Yeah. Okay, so that word hasn't actually been mentioned explicitly in any of the previous examples that we fed into the system, but yet we still want the system to be able to interpret that text and return back, this is somebody talking about service. Okay, so that's quite a complicated leap to make, and in order to make that kind of leap, we have to go just beyond basic text matching and use proper machine learning. So when I press next here, again, Nebu has sent the text, the barista was very friendly to me, to the Codeit API, and the API has come back and said, this person is talking about service, and I'm 99.2471% confident about that. Okay. So what's going on here is, although we haven't set up any specific text matching rules, and we haven't got any exact examples that match this text here, the system is still able to make the connection between the text that the respondent's given and what it's learned from these 956 coded examples that we've fed into the system. So obviously, if somebody had previously said exactly this phrase, then great, we can short circuit the whole machine learning level of the system and just return back whatever codes were applied for that verbatim last time. But to get a sensible theme out of this text, without that, we have to sort of dig into the machine learning model and find the theme on that basis. So the way that the machine learning model has been built is from the user's point of view, completely non-technical. We just we loaded these 956 examples, we coded them, and behind the scenes the system built a model and learned how different things or how different things will be coded as items within this code frame. And so, based on the examples, it seemed, maybe to do with friendliness, maybe there's other people talking about friendliness. It's learned that sort of thing relates to service, and it can make that suggestion off the back of that. Okay, if that makes sense. So jumping back to Postman again, let's see what happens if I say the barista was quite rude to me. same thing. It knows this is about service at a 95% confidence level. Let's say let's try another example. The place was filthy. Again, I'm pretty sure within our body of examples that we've given it, nobody has said the word filthy hasn't come up in any of the examples that that we've fed into the system, we've trained on, but the system's still able to detect that this is the topic being talked about here is cleanliness. So from quite a small number of examples, less than 1,000 here, the system is able to build a machine learning model which is quite effective at categorizing as yet previously unseen verbatims or phrases or ways of expressing things. So what that saves us is, instead of having to think of every possible example or every possible thing that can come up, we can just feed in examples of the sorts of thing we're looking for, and the machine learning will sort of fill in the blanks. As I said at the beginning, machine learning can't just magically know these things, but if you give it enough examples to work with, it can start making quite clever links between what's coming in from the respondent here and what it's seen before. As an example of that, let's supposing I misspell this. Hang on, no, that's a step too far. How did I do this before? Yeah. Okay. So if I've misspelt it, I've dropped a letter there. You see that under certain circumstances it can still do a reasonable job of detecting or categorizing that verbatim into that theme. Obviously that one was a step too far, but hey. So it's not even like the text has to be always 100% accurate, and obviously with surveys there are going to be typos and messy aspects to the data, and in spite of that, the AI can still often do quite a good job of categorizing that data. When I was testing this yesterday, I was trying a few colloquial phrases. The place was grubby, and it's still able to recognize that is somebody talking about cleanliness. So I've used a fairly it's not quite slang, but it's it's a fairly colloquial term, and it's still able to sort of make sense of that, because the AI itself has access to what's called word embeddings, and they are gleaned from vast corpuses of text and allow the machine learning to sort of infer connections between words and connections between concepts. So if somebody has talked about dirty in the examples we've given it, and then a respondent says the word grubby, the machine learning is capable of sort of making those links and connecting those things together, very much like the human brain is able to do as we learn things. Okay, so then one last little thing I want to show you is within and now I'm jumping to, sorry, I'm sort of jumping around a bit here, but on our Swagger page, it's sort of a bit like Postman in that it allows you to test out our sort of AI and text analytics endpoints, but within from a nice simple to use web page here. In addition to being able to provide build models around training examples and predefined code frames, the Codeit engine, AI engine, has a sort of a layer of text analytics built into it that you can also sort of tap into. And I think Peter showed some of this a little bit in the previous session. But But if I say something like the barista was rude to me, you'll see that the text analytics engine can parse that text and pull out, the things that it thinks, or the keywords or the phrases that it thinks are pertinent within that bit of text. So it's detected that this respondent is talking about the barista being rude, and that's a strongly negative comment to make. So that's obviously doing a slightly different thing, because it's pulling out sentiment. Whereas when we're using the machine learning to categorize against a predefined code frame, that's obviously looking for theme. So in my postman example here, let's do the same one. That's food to. So the machine learning model can tell us this person is talking about service, so the predefined code that we're interested in there, and the text analytics can also give us a measure of the sentiment involved, and then by combining those two within the questionnaire. So let's go through this. Why did you visit the cafe today? I was meeting my friend. Then it'll ask me a follow-up question relating to meeting friends, and then I can say the barista was rude to me. Okay. And so by combining those two things together, we know that the person has said something quite strongly negative, and that it's a strongly negative thing about the theme of service. And so we can then combine those two things together to ask a question within the questionnaire to say, okay, specifically, sorry, the service wasn't satisfactory. What could we do to improve? So be less rude might be a start. And there we go. We can, because we're on the topic of service, we can ask them to give us a rating on that, and then that's the end of the questionnaire. And that's pretty much the examples I wanted to show. I kind of appreciate I sort of skipped through a few bits here and there, but I'm hoping that that from a fairly high level, this that will have given you some sort of insight into the sorts of things that are possible within the Codeit API, and how you might tap into those services to code things in real time in your Nebu questionnaires. And that's it, I think.
Thank you, team. Thank you so much. It's very interesting and very well explained. There's sort of a conversation going on in the chat room. Of course, you couldn't follow that, but Rudy is answering questions. Rudy, do you want to also unmute? Maybe you want to answer to everyone. Maybe not all attendees are actually reading the chat, and this is the perfect moment also for everyone. If anything comes up your mind, please ask us. Ask our panelists a question. It's the perfect moment. You can always take it further in a more personalized demonstration, but it's a good moment to ask a specialist anything you want to know about AI and you didn't know who to ask for.
Great. Yeah, I was impatient. I just like to answer people's questions quickly, but I figured we'd return to them. We've had a couple of questions about, of course, in all of this, usually most of the questions I hear, and of course you've heard and seen posed in many conferences, is about things like accuracy, to use a big word. you know, is it correct? How often is it correct to making these judgments? And certainly with text matching capabilities and the text match rules, you can make it very correct. It's really up to you as to how general you wish to match any specific text within verbatims. When it comes to the AI, the machine learning and the natural language processing course, there's some variability there. And Jacob's been asking some intelligent questions about, you know, multilingual, how do we handle that? And what about very specific idioms people use in different languages, or even indeed within the same language within a survey. He brought up the classic example of someone saying, hey, sick, you know, I'm sick with coronavirus is one thing, which I'm not. That was a real sick commercial. Or that was a real, I had a survey of younger adults about sick skateboarding moves, things like that. So it can mean things. There's lots of words like that. Hard and bright are two others that can fluctuate in meaning. Things can be too bright or a bright person, and you know, things are hard to understand, or I like a good hard tabletop. So there's a lot of that.
I think with the sick example, you know, the example you quoted there, you know, I was sick with coronavirus. You know, there is enough context within that particular statement for the machine learning to know, oh, right, this person's probably talking about being unwell, right? Because there's extra information in there that helps disambiguate the word sick, right? Now, if somebody says, you know, what did you think about the cafe? And somebody just put sick, you know, then it goes back to my example about, you know, the pizza being really cheesy. You know, if I just say it was really cheesy, or if I just say sick, you know, a human and an AI couldn't, neither of those can make a definite judgment on that particular bit of text, because there just isn't enough information to know you've definitely got it right, you know. And it's the same with the other classic example, which is you know, someone being sarcastic. You know, if somebody says it was great, but they actually meant it in a sarcastic tone of voice, you know, you're just not going to know that from the text. So those are insurmountable problems for people and for AI. But fortunately, in the world of research, you know, these examples, they loom large in our mind because they're difficult and awkward, but actually they don't come up very often at all, really. It's pretty rare that somebody would just say sick when they're answering a question about what they thought about, you know, the last visit to a cafe. See what I mean? So they're good hypothetical examples, but they're less of a problem than you might think.
Yeah, it comes down to, you know, how significant are those types of comments going to be, and how prevalent are they when it comes to the final report in the analysis? You know, if you're going to use more automation and machine learning and NLP, you need to move to more predictable categories and actionable categories that are going to be meaningful in the end. If everybody's saying, you know, that was a real sick movie, and meaning it was a good movie, you know, if it's very prevalent, it's a real easy, there's an easy solution just using standard coding methods for that. And, you know, we can adjust the automation within the survey if that's really what we want to do. You just have to be careful, because once you start changing the rules, you know, you change all the rules. So that's just the general answer to that. There was another question in there, Tim, about how we handle multilingual responses. I tried to reply that, you know, it's beneficial to these learning algorithms if you focus on a single language, because you can, you know, you increase the number of different examples around each category that you wish to try to auto-sense. So included within Codeit is an auto translation feature, a machine translation feature. And I hate to use it, but the translations tend to be accurate enough, good enough, so that we can still efficiently build the learning model to accurately, you know, produce results that can be sent back to the survey or for the coded results.
Yeah.
And that's
Well,
that could be done automatically in stream as well.
yeah, it can be done on your side, but it also could be what we did for our NPS questionnaire, that there is an actual HTTP request call for, I think we use Microsoft Translate services. It can be Google Translate services, in a way that you keep your native language in one column and translate the text in a different column. And it's also a question of a setup, which column, which variable you're sending to code it, right? So we might already from here, from the questionnaire, send all English text after them being translated. So there are two ways to do that.
Cool. There's also a question in there about expletives.
Yeah.
So the question's asking, can you rule them out? So yeah, our text analytics has the ability to detect profanity. Am I allowed to do it?
Oh, yes, it does.
Am I allowed?
You could do a gentle one.
I do a gentle one. Okay.
Just say dirty. That will be cool.
How many people? We're not going to offend that many people, are we? How many people? I know Roland will find.
Right. There you go. So the barista is obviously being very rude to this person, and the text analytics will detect that as unambiguously profane. Peter, was your example was the barista was dirty?
Dirty, yeah.
Yeah. Okay, so that's detected it as possibly profanity based on the context, but you see that's been labelled as ambiguous profanity. So yes, it can detect expletives, and actually there's two layers of that, because there's some words that may or may not be as profane as others. If that makes sense. So obviously, depending on how you script stuff in your on the Nebu side, you might want to look for these results coming back from the Codeit API, and then strip those words out, or whatever, flag the interview as needing checking or possibly censoring, or whatever it is you want to do on the back end. And this all works in like many languages too. So if you're not an expert on all the Japanese swear words, then it's fine. It doesn't matter. This will automatically take care of that as part of the process.
There you go. There are actually quite a few other byproducts of the natural language processing. People are mentioning basically people, places, and things, and lakes and mountains, and any kind of named entity will also be returned, and you could use it in some way within the script if you were looking for a specific mention that way. Yeah, cool. Just sentiment.
Yeah. Okay. Another question come in. Can you explain a bit about the accuracy of the AI coding? So there's a complicated answer to to that question, which is if I go back to my Postman example here. So the text I've got here is: the barista was rude to me. Okay, and so it within the sort of back end of Codeit, the engine will sort of process that text, and then try and sort of place that within the model that it has. So it tries to find what is the most likely code for this text based on all the other texts that have got built into the model. And depending on how close that example is to other examples that we've seen before, we can generate a confidence score. So this is it's kind of a distance measure, but it's telling us how close this text is to other examples we've seen before, and therefore how confident we can be that this is definitely, someone talking about service. Now, you can decide on what level of confidence is acceptable for you. So the question about accuracy, the reason why this is a complicated answer, the question about accuracy is, well, it depends what sort of confidence level threshold you set. So if you set your confidence threshold to 100%, for example, so take an extreme example, then the accuracy will be pretty much 100%, right? But obviously the amount that the AI can do for you is limited if you set the bar that high. Now, what we found with our experiments is that if you set the bar at about 80% confidence, then you will typically get a 5% error rate in the coding that comes back. And we think, being a little bit generous, we think that 5% error rate is probably about what people perceive to be the human level error rate, because obviously goes without saying humans are not perfect either, so humans make mistakes. So if we assume that 5% of the time humans get it wrong, then setting that confidence score to 80% will emulate that in terms of the suggestions that come back and can be set automatically. Does that make sense? Hopefully.
That's a code by code basis as well. So, this whole approach is confounded by longer verbatims with more codes in the code frame. Having enough examples around those so that we can predict things at those higher levels. There's a lot of variability here, but it really depends. The answer to this is another classic accuracy question: how does it compare to my humans? It depends. It depends on how many good examples you've provided along the way.
And I think also it's probably worth pointing out that it's definitely not our aim to eliminate people from this process at all.
That's a good point.
There are people out there who will tell you that this can all be done by humans, and those people generally have no experience of market research. Market research has got very specific requirements. It has very kind of detailed, nuanced code frames. It has a need for very high accuracy. There are lots of sort of hurdles in the world that we occupy, which mean that the AI can't do everything. If somebody gives you 2 paragraphs of a verbatim that's 2 paragraphs long, there isn't an AI in the world that can categorize that to the standard that is expected of market research. So, what I started out by showing I'm logged out now, but I started out by showing the manual coding interface, and to some extent, there will always be some items that will fall into the bucket of needing to be looked at by people, and therefore it is important to be able to allow people, keep people involved in that process, and bring them in to fill in those blanks as they crop up.
Right. That's a very good point. Yeah, and we've made it easy, so coders just code, and as they do that, they are providing examples for the learning models. In Tim's example of setting the confidence to 100%, we have another capability where we can still show suggestions at lower levels and then let the coder decide. So in a coder world, I could mark up the verbatims with suggestions from a learning model and let the coder decide, for instance, suggestions below 80%, if that's a good example or not. And in doing so, they are teaching the algorithm even further, because those are, if you will, those are suggestions to phrases and things people say that are on the cusp of being automatically coded versus being below that threshold. So you're sort of focusing the coder's work when you need it most. So this ability to show suggestions is really ideally how we see using a tool like the machine learning in a world of coding. Yeah.
Okay. I think that's, if there's no more questions, I think that's more or less it.
I have a question to Peter. because for the next webinar we are working on implementing into a questionnaire voice to text recognition. Well, it's almost implemented. We will show that shortly in one of Marketing Research Society webinars. And the question is because Tim, you were joking about respondents who say great. In a way, it's great. And is there any way that when we have voice to text, Peter, there can be a tone of voice recognized, or is it just voice to text and translation?
As far as I know, there are some trials already that try to also check the tone of the voice. But the guys are the experts in this. As far as I know, where we are with AI right now, it's more about just understanding the words in different accents and different languages, more than detecting the tone as well.
Yeah, I mean, yeah, there's some work that various people are doing in terms of trying to detect emotion within the text, within speech, and so, I think that's the next frontier. People trying to find out if someone's angry or happy or sad or whatever.
Yeah, our underlining message. Yeah.
I mean, in call centers. There's all sorts of clever software that will monitor sort of basically someone's kind of the caller's anger levels throughout the call, because obviously it's often it's the agent's job to resolve problems, and so a lot of call center agents will get scored on how much they can turn around the emotional level during the call, because you obviously expect the person to start angry and then be joyously happy by the end of the call. So, detecting kind of that sort of thing, the emotion and that's going on in a voice is, I think the main thing people are looking at the moment, and then going, sarcasm, I think is a level beyond that. I think it's probably easier to detect anger, because the thing is with anger is it's sort of not only in your tone, but it's actually in the words that you use, and perhaps the kind of the tempo of the way you're speaking. Whereas sarcasm is a very, very subtle thing. I think we're way off computers being able to detect that yet, unfortunately.
Yeah, that's true. We as humans have sometimes difficulties recognizing that.
That's very true.
Yeah. Wow, I really enjoyed this presentation. Thank you so much. Are there any last questions, something you want to take during the session? You're always welcome to send us an email post-webinar. We will be more than happy to take it further with you. Yes, we have.
Dijon, the best thing to do is I'll have your contact information if any of you want to use your own specific content, either through the survey process with Nebu, or of course all this works in batch mode, where we can take a lot of comments and quickly break them into the themes. We have some tools that assist in that. We're more than happy to sit down with you and demonstrate some of this, and even give you some trial access to the application so you can play around with it.
Okay. Thank you.
Great stuff.
Okay. Yeah, I think this concludes today's session. There will be more coming up in the near future, so please keep an eye on our coffee demo, and always feel free to reach out to marketing@nebu.com. I will be more than happy to connect with the specialists. And yeah, thank you so much. Thank you, team. Thank you, Rudy. Thank you, Peter. Wishing you really great rest of the day. Be safe, stay safe.
Stay home.
Stay home. Yes.
Go do some more laundry, clean yet another room.
Yeah.
Rearrange magazines, anything. Thank you.
Yeah.
All right.
Special times.
Yeah, it's great.
Hang on. That was definitely sarcastic.
For all of you who are stuck in your your social distancing with your children, I feel for you. I'm beyond that mark, so I'm enjoying my solitude.
Yeah, it's
Can't
hard
imagine
work.
having kids.
Yeah, it's hard work. Just
Yeah.
you shove them out in the garden and leave them out there for the day. Yeah, that's my technique. That's what the shed's for at the bottom of the garden.
That's right. All right.
All right. Cheers,
Thank you
guys.
all.
Thank you.
See ya.
Goodbye.
Have a great day. Bye bye.